Similar triangles and trigonometry. Recall that Thales found the height of the pyramid by using similar triangles created by the shadow of the pyramid and a rod of known length. But what if he were trying to solve this problem and there wasn't a shadow to use? Or what if you were trying to solve other types of problems which don't allow you to set up a similar triangle so easily? Well, trigonometry provides the needed similar triangle for any circumstance, which is why it is such a powerful tool. If Thales had used trigonometry to solve his problem, he'd have considered the right triangle shown below. First, he'd measure the angle labeled theta, which is the angle between the ground and the top of the pyramid when at a certain distance away on the ground. And then he'd imagine a similar triangle with the same angle. He has a ready-made right triangle thanks to mathematicians who calculated all of the possible right triangles that could be created with a hypotenuse of 1 and put their measurements in a table, a trigonometry table. The side opposite the angle is named sine of theta, or the abbreviation SIN, and then the Greek letter theta for short. And the side adjacent to the angle is called cosine of theta, with the abbreviation COS, and then the Greek letter theta. We know all the angles are equal in these two triangles because both triangles include a right angle and the angle theta. And therefore, these two angles, or angle pairs, are the same in both triangles. And since all the angles of a triangle total 180 degrees, all three angles must be equal by the third angles theorem. And then since all the angles in the two triangles are equal to one another, these two triangles are similar. Since all the angles are equal, the sides are proportional and we can write a ratio. If we do height over distance, so height vertical, distance horizontal, that's going to be equal to sine of theta, which is vertical, over cosine of theta, which is our horizontal. When we did the problem earlier, we used similar triangles to find the height of the pyramid. At that time, we had a rod of length 1 meter, and its shadow that it cast was 2 meters. And this was proportional to the height of the pyramid and the length of its shadow, 120 meters. Now the rod's height of 1 meter and the shadow of length 2 meters provides us with an angle between the rays of sunlight and the ground. So right here and right here, which is found to be 26.6 degrees. An explanation on how this angle measure is found will be explained a little later on. But let's use this angle of 26.6 degrees, the shadow's length of 120 meters, and the sine and cosine ratios that we have in these similar triangles to see if we get the same answer for the height of the pyramid. If the distance was 120 meters and the angle was 26.6 degrees, you find the height by solving for it and then using your calculator to look up the values for sine and cosine of 26.6 degrees. So we're going to have height over 120 meters is equal to the other height, sine of 26, divided by the other horizontal distance of cosine of 26.6 degrees. So again, height over distance equals sine of theta over cosine theta. And then if we substitute those values in, we get this exact ratio that was stated. And now if we cross multiply, we'll have that the height, unknown h, times the cosine of 26.6 degrees is equal to 120 meters times the sine of 26.6 degrees. And then if we divide both sides by cosine of 26.6 degrees, we will get that the height is equal to the sine of 26.6 degrees times 120 meters divided by cosine of 26.6 degrees. And if we get the sine value of 26.6 degrees and the cosine value of 26.6 degrees, it ends up being about 448 thousandths over 894 thousandths times 120. And when you multiply and divide all those values, you do get a final pyramid height of 60 meters. In the last problem, we found that the ratio of height to distance resulted in the proportion of height over distance equaled sine theta over cosine theta. This ratio of sine theta to cosine theta is used very often and has its own name, called tangent of theta, or the abbreviation TAN, and then theta for short. The tangent of theta is defined to be the sine of theta divided by the cosine of theta. And here's how it's written as a ratio. We're also going to be using calculators with trigonometry. The final step of the last problem required us to find the values of the sine and the cosine of 26.6 degrees. When working with trigonometry, you'll need to find the values of sine, cosine, and other trigonometric functions, or trig functions for short, when given an angle. This used to involve using tables, but now it's pretty simple to use a basic scientific calculator. Basic scientific calculators are available on computers, tablets, and smartphones. They can also be a separate device, similar to the inexpensive calculator shown here to the right. It can do everything that you'll need for this course. The trigonometric functions, or trig functions for short, that we are going to be using right now are the sine, cosine, and tangent ratios. And on most calculators, they are noted by buttons which say their abbreviations. So SIN means sine, COS means cosine, and TAN means tangent. So the SIN, or sine button, is for finding the sine of an angle. The COS, or cosine button, is for finding the cosine of an angle. And the TAN button is for finding the tangent of an angle.